Hi again, everyone. So today we're going to continue with the notes from yesterday. These are the multiplication of exponents notes. We're going to wrap these up, and then we're going to go on to division. So if we could just start with example 16, please, based on like now you went over your homework, maybe you have a different understanding of what you did last night on homework. Everybody try example 16, pause the video, and try example 16 on your own, and then I'll go over it. Okay, so first we're going to start with raising -2 to the negative first power. So -2 to the negative first, think about -2 to the first is -2. So it's the reciprocal of -2, so it's just -1/2. Okay, I'm going to multiply exponents. I have a to the negative third, 3 times -1, and b to the negative first. You'll notice that I set these up this way on the homework assignment when I showed the work. Now I'm going to raise 3 to the negative third. Remember, 3 to the negative third is the reciprocal of 3 to the third. So if 3 to the third is 27, 3 to the negative third is 1 over 27. And then I'm multiplying exponents on the a, so a to the negative 12th. I can now go side by side and multiply the -1/2, this fraction times this fraction. So -1/2 times 1/27th, just multiply the numerators. 1 times 1 is 1, and it's negative. So -1 over 2 times 27 is 54. And then I'm going to go through with the a's. I have a to the, I'm adding exponents, right? So -3 plus -12 is -15. If you are comfortable taking that shortcut that I showed you yesterday, where you just directly put it in the denominator, feel free to do that. I'm just kind of doing it more step by step. And then b is to the negative first. Both of these are going to go into the denominator because it's the reciprocal again, so it's -1 over, and then it's 54a to the 15th b. Notice again that they become positive exponents once you take the reciprocal and put them in the denominator. Okay, so that's like a recap of yesterday, reinforcing what you did at home on the homework sheet. Okay, now we're going to sort of move on to a slightly different topic, which is numerical bases. So numerical bases, if you look at these problems, what you'll notice is that there's no variable. So normally we see like x to the third times x to the fifth. The base, meaning the thing that's holding up the exponent, the base is a variable usually. Right, so we have x and x, that's the base. So we usually just carry over the base. We copy the base and then we add the exponents, right? Now, sometimes there's a number multiplying in front of those bases. We call that the coefficient. So sometimes we might have like 6x to the third times 6x to the fifth, in which case the coefficients we know get multiplied. 6 times 6 is 36. And then again, the base is x, right? So my base x just carries over x to the, and then 3 plus 5 is 8. In these problems, now look at 17, the base is the 6. So the base is the number. That's why we call it a numerical base. So I'm going to write down here base. So what we're going to do is we're just going to carry over the base. We're going to copy the 6, just like we would the x, and we're going to add the exponents. So it's going to be 6 to the 8th power. And then you figure out what that is on your calculator. Okay? So the reason is that 6 to the third is really 6 times 6 times 6, and 6 to the fifth is 6 times 6 times 6 times 6 times 6. So altogether, how many 6's are multiplying by one another? 8 of them. Okay? Just like we did with the x's, only now it's a number. So the 6 would only get multiplied like over here in this situation if it's in front of the base, if it's a coefficient. That's when you multiply those. But if it's acting as the base, then you just carry it over. And then you could do the final calculation in your calculator, 6 to the 8th power. Okay, 6 to the 8th power is a very large number, so it's 1,679,616. Okay. Most values are not going to come out that large, but here's another example. Again, this -7 is the base, so I'm just going to carry over the -7, copy the base, also copying the parentheses, and I'm going to use my laws of exponents, which say I add exponents when I'm multiplying. So 2 plus -4 is -2, and then I'm going to simplify this. So think to yourself, what's negative 7 to the negative second power? Practicing those negative exponents, it's the reciprocal of negative 7 squared. So if negative 7 squared is 49, this is 1 over 49. Notice it became positive because my exponent is even and I have those parentheses. Okay, so for these problems, the most common mistake I see is that kids will actually take on the calculator, they'll start multiplying the negative 7s here, and the instructions are going to say using the laws of exponents. So the work, using the laws of exponents. So the work has to look like what you're seeing here, where you're adding exponents. Or if you look at example 19, now we're going to be using a little bit of a power rule. So we're going to be multiplying these exponents. So first I'm going to have 4 to the 3 times 5 is 15th power. And then 4 to the 2 times negative 5 is negative 10th power. That's me using the laws of exponents where I raise a power to a power. Now I'm going to use the laws of exponents where I add the exponents. So here I was adding, here I was multiplying, and I now have, again, bring your base over. 4 to the negative 15 plus 10 is 5. So 4 to the 5th power. This is the only point at the very end where you can go to the calculator and figure out what 4 to the 5th power is. 4 to the 5th power is 1024. Okay, you're not allowed to use your calculator back here to do 4 times 4 times 4 and then to the 5th power, etc., etc. Okay? All right, so this is the end of multiplication, and then we're going to go on to one more thing, which is division next.